If you have a pointy electrode and high voltage, you can actually generate ionic thrust. So you generate a wind that moves away from the electrode. This is a Wimshurst machine that generates thousands of volts. And it blew it out. You can even get sharp electrodes to spin in a circle. And what that means is if we can create a plane that has an onboard power supply that can generate this high voltage, all you need is the pointy end pointing away from the direction you want to go. It will create this neutral wind that moves this way and pushes the aircraft this way. Now you may have heard of ionic thrusters before in relation to propulsion in space. So why don't we test out if you can actually use this method to propel something in a vacuum. So you can see that it's easily spinning in there, but let's turn on the vacuum and see what happens. 3, 2, 1. Still going. It might be slowing down though. Okay, we're at 0.1 atmospheres now, so we're getting down to a pretty good vacuum in there, but there's still some air. And it's stopped. Okay, so we're at a full vacuum now, and it's not able to propel itself forward using that ionic thrust. So all you need to do to get an ion thruster to work in space is you need to bring the gas with you. There's no gas in space around you, so you supply the gas that's going to get propelled out the back. And the way it's going to get propelled is not through combustion like a typical rocket booster, but you're actually going to propel it using these electric forces and cause it to be ionized, create this neutral wind that gets ejected out the back, and it pushes the aircraft forward.